Evaluating trig ratios from a given point in the coordinate plane. Let's say we have a point, random point called xy, and xy is sitting in the first quadrant. What we can do with this point is we can create a diagram of a right triangle, and this is how we begin getting our trig ratios from any given point in the coordinate plane. From here we can use some labels. Adjacent to the central angle is the x-axis, so that's my x value. Now vertically is my y value, so that's my y value. And the hypotenuse, we're going to call that r. So now I have a right triangle with a hypotenuse of r, and I have legs of x and y. Since r is the hypotenuse, we're going to label that hypotenuse. Y is opposite of the central angle, so y is the opposite, which makes x the adjacent. So sine theta is equal to the opposite over the hypotenuse, which means this will be, let me zoom in, which means sine theta is equal to y over r. Cosine theta is adjacent over hypotenuse, which makes cosine theta x over r. And then tangent theta is opposite over adjacent, so that's going to be my y over x. And we cannot divide by 0. Now these are your basic 3 trig ratios. There are 6 total, and the other 3 are only the reciprocals. So the reciprocal of sine is cosecant, which is CSC. And so the reciprocal would be r over y. And remember, we cannot divide by 0. The reciprocal of cosine is secant. So secant theta will be r over x. And we cannot divide by 0. And our last reciprocal is cotangent. So cotangent theta is x over y, and we cannot divide by 0. So what we're looking at here is we're looking at the diagram of the generic right triangle that sits in a quadrant and the generic definitions based on x and y values for any right triangle that lands in any quadrant. These rules are very, very, very important. It's going to be through these definitions where we can find the trig ratios of any point that lands in any quadrant, even the ones that land directly on the x or the y axis. All right, so we're going to take a look at our first example. So we have that out the way now. So our first example, we're going to take a look at something that is, I want to start with the second quadrant. All right, so I'm going to get an XY axis drawn out here real quick. And now I'm going to put a point in the second quadrant. So let's see, I think I want this point to be -3, 4. -3, 4. So my triangle now comes from the origin and it connects to my dot here. And now I connect it back to the x-axis. And now, as you can see, I have a right triangle that sits in the second quadrant. So now here comes the correct values. Remember, the x-axis is your x value. So your x value is a -3. Your y-axis that's vertical is your y value. So that means my vertical side is the y value, which leaves me with the hypotenuse as the r. If I need to find a missing side, or if there's a missing side that I can't figure out on a right triangle, all we have to do is use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared is equal to c squared. But since I'm using the coordinate plane, I'm not using a, b, and c. What I'm using is x squared plus y squared is equal to r squared. So it's the same theorem, I'm just using different variables now. So let's see how this relates to my diagram now. I have x squared plus y squared is equal to r squared. My x value is a -3, my y value is a 4, and my r is what I am getting the value for. This gives me 9, this gives me 16, and there's my r squared, and here we go. 25 is equal to r squared when r is equal to 5. So now I know what r is equal to. R has a value of 5. So my central angle sits right here. And now that I know all three of my sides and their values, I just use those same definitions from earlier to list out all 6 of my trig ratios. So I'm gonna zoom in this way. So that means my sine theta is equal to y over r, which is 4 over 5. Cosine theta is my x over r, which is a -3 over 5. My tangent theta is y over x, which is 4 over -3. There's my first 3, and all I need are the reciprocals. Cosecant, 5 over 4. Secant, -5 over 3. And then cotangent. That happens to be a -3/4 now. And there are all 6 of your trig ratios. One very important thing to note is that when you start doing these trig ratios from a coordinate plane, once you leave out of the first quadrant, some of your functions will be negative, some of them will be positive. This example in particular, it was in quadrant 2, and by looking at all of our values, we can see that the 2 functions that are positive happen to be sine and cosecant, and that's always the case. Sine and cosecant will always be positive in the second quadrant. Now the other ones won't. Notice there's my negative, I have another negative, I have another negative, and another negative. Sine and cosecant is positive in the second quadrant. The remainder is negative. So this is the only example that I wanted to do for this video. I hope this makes a lot of sense. I will be doing a couple of more of these types of videos in the next coming days. Remember, you can find me on YouTube. Just do a search for BJ Jeffries, spelled just like that. And then you see this icon right there. That one right there. That's how you know you're at the right place. So you can subscribe to my channel by searching my name here. Look for this icon, and I have a lot of videos that you can look through over various topics: high school, elementary, middle school, all of it.